I am Haoning from SECTE 45A, and today I'm going to give you a brief introduction for my thesis called Redundant Reader Elimination in Large-Scale Internet of Things City Networks. First of all, I need to introduce the RFID. RFID system is an important communication technology for object identification and tracking, usually including three components: tanks, readers, and a central processing system. For its working principle, the tanks can be attached on the object. The readers can scan the tanks to get the information about the object, such as the time, the name, and after that, the readers can set information to back a database to process this information. For its application, it can be used in many areas, such as industry, retail, especially in warehouse. As we can see from this picture, there are a lot of robots around the parcel. Actually, this robot can use RFID technology to identify their target parcel to set them to their destination. I think this can help workers to reduce their workload and increase efficiency. However, as the number of readers and tanks increases, energy loss becomes an issue that needs to be addressed. Today, one of the problems is the redundant reader issue, which means multiple readers cover and interact with one RFID tank or many same tanks, thereby resulting massive energy consumption. So what's a redundant RFID reader? As we can see from this environment, there are 4 readers and 3 tanks. Actually, only the middle reader 1, covers all the tanks. Therefore, the rest of readers are considered as a redundant reader. So we have to eliminate this. As we can see, this is a large RFID environment in which there are many tanks and readers, which may result in huge energy costs. We need to make sure that all the tanks are covered by the minimum readers. To solve this problem, I reviewed many redundant reader elimination algorithms and picked the 3 typical algorithms to compare each other to see which one is better. The 3 algorithms are redundant reader elimination algorithm, 3 count-based algorithm, and the threshold selection algorithm. Next step is to explore their performance in programming. This is MATLAB. In MATLAB, I coded the 3 algorithms and simulated 50 multiple 50 environment, including 50 readers and 50 tanks. I set the coverage of readers is 10, which means 1/5 of the environment. For the first algorithm, I adopted the recommended input parameters, which is 9 and 2.2. For the other 2 algorithms, TCB-RE, their input parameters are the same. Okay, let's run it. Okay, here is the result. As we can see, in this environment, the TCBA can detect more redundant reader, which is 37. The next one is RE. It detects 31 readers. The worst performance in TSA, only 29 readers, which shows TCBA is good in detection accuracy. But I think the size of environment is not large, and also a little bit not accurate. Next, I will set a large size of environment and also to measure the running time to say which one use shorter time. Okay, this is the result, and we can see from this, the TCBA has the best performance in detection accuracy. It detects 86 redundant reader. However, RE only detects 77 and the TSA is 76. However, for its running time, the TCBA costs a long time, 100 seconds, about 100 seconds. But for TSA, only 13 seconds. Wow, I think TCBA is not efficient, but TSA is more practical to satisfy the real environment's needs.